Right, so we'll just screen share. So let's open Replit again, and then let's just go back to what we made last time. I just cleared everything because I'm going to teach you guys some new things today, but you can keep what you have last time as well. If you have Replit open, type in chat, and then this way I will know when everyone's ready. All right, so are we all on Replit now? Well, okay, so today let's talk a little bit more about lists. So last time, so if I had like, I don't know, like numbers equals maybe 1, 2, 3, and then 5, 4. Well, we could like take a certain thing in this list, right? We could have done this. And if we print it, this just gives the first thing. So this is what we did last time, right? So you could actually do like number sets, just more functions to this. So one of them is like sort, and this, well, it sorts the list, right? So we just like messed up a little bit more. It sorts it. And that's one of them. We can also do numbers.copy. For example, as if I say numbers 2 equals numbers.copy, and if I print numbers 2, well, it's the same. It's a copy. And this can come in handy in a lot of situations. And well, so instead of like getting a single element, if I say number, actually, if I just print numbers at, in Python, you could actually do this, 1 and then colon. Now what this will do is it will take, starting from the second element, and it will take everything after it. Well, if you do from 0, then it's just the entire list, but this is how you can even do like from basically anywhere. And just say like, and like on the other side, you could say like from the second one to like the last one, but it excludes this number. So it includes the first one and doesn't include the last one. So only these are selected, starting from index 1 and ending at index 4 exclusive. So that's how you do slicing. Now, if you don't want the front one, that also works. And well, so this, are we all good so far about all these functions? All right, so instead of saying like numbers at what position, right? Like this works, but if you want like the last element, then you have to go like length of numbers -1. This will give you the last number, right? But this is very long. So instead, in Python, you can actually do index of -1. and this will give you the last element. Now -2 is the second last. So you could go all the way to like -5 in this case. Now if you go like more negative, it's gonna throw an error. Say out of range, just like how you would with positive. But with negative, it makes it very, very convenient to just say, oh, read the last element of a list. And well, a list in Python can actually have like have multiple data types. You can store numbers and characters, and they'll all go in the same list. Right? Are we going so far? So let's talk about some more list functions. So if we have a second list, say characters, and we have A, B, C, D, and like E. So there's a function called zip. And what it does is, well, imagine it as like a zipper. Now, if you try to print this, well, it's going to print, well, zip object at whatever, whatever. So what we can actually do is we can convert it to a list. Now we can print it. Now, well, what do we get? We get these two lists paired together like zippers. Now, inside the list, you see like parentheses. Well, let's talk about those. What exactly are these parentheses? So in Python, there's actually, other than lists and strings, there's actually another data type called a tuple. So you can have like pair equals 1 and 2. Well, it's a tuple. For the most part, it functions mostly like a list. So you can say like print pair index 0. It gives you 1. Print a -1. And it's 2, right? But the difference is that, well, in a tuple, right? If you like pass it in through a function, then if the value is copied, but it's only basically they're kind of the same thing, but pair like tuples are used in different situations. Most of the time, you would just use lists. Also, here's a trick to like reverse the list. So we talked about the colon, right? Start, and so you can actually do like a separation. So if you do like colon 2, it takes every second element. If you do double colon 3, well, it takes every third element. Well, what you can actually do is you can do -1, and it reverses the entire list. So this is how you would reverse an entire list. And well, for tuples, well, tuples, it can be more than a pair. you could go way beyond 2. You could do like this, right? And if you try to slice it, it also works. So it's kind of just like a list in these situations. So well, what are the differences? So if you make define a function, and then we're taking like basically anything. So if you're just taking like, I will just call it a for simplicity's sake. And if I say like for everything in A, so I can just say like for number in A, actually for I in range of length of A. This way we can change what A is directly. So if we try, so we can just say like A index I increase by 1, and then that will be it. So if we do F of numbers, and then we print numbers, what will happen is that everything in numbers has been increased by 1, right? Because, well, we pass numbers into A, and then it increased everything by 1. But if we try the same thing with, say, like the pair, it doesn't work the same. And it doesn't even support item assignment. So you cannot actually change anything in a tuple. You can access it, kind of like a string, but you cannot change it. So it's basically, rather than a list, it's more like a string, but then it's kind of like in between. You can still have the same like elements, just like a list, but then it's also like a string where you cannot really change it. On that note, all these list notations also works on strings. So if we have like word equals hello, and then if we print word reversed, we can actually just have a reversed word. Well, slicing also works with words. So if you want like everything until the last one, you could actually just do this if you want. And well, this also works. It takes every other character and it joins it. So all these functions, I mean notations rather, they work on lists, and strings, and tuples. I'll be back in a bit. I'm going to get some water. Okay, I am back. I've returned. All right, so more about lists and tuples. Well, you could actually have, well, a list of tuples. So if you have like coordinates, say like on an XY plane, right? So you have like 0, 0, 1, 2, 4, 3, something like this. And if you try to change the value inside, well, there you go, right? You can also, you cannot change what's inside the tuple, but you can just change the entire tuple. So if you do like 3, 4 for the second element, well, you can actually just change it, right? But just like how you cannot write or change anything in a tuple directly, if you try to do this, and well, I guess that'll be out of indexed out of bounds, but if you try to do this, where you try to take the first thing from the second thing in the list, so if you try to take this one, and if you try to overwrite it with another value, then there you go. Tuple object does not support item assignment. There you go. Yeah. Now just to show you guys how tuples and strings are a bit different from lists, right? So we had a like an f of define f of a and then change everything in a by 1, and then this change a list, right? So if you do f of numbers and print numbers, everything will increase by 1, just like we did before. So let's get rid of this error message thing. So everything increases it by 1 as expected, right? Now since we can't just directly change, well, pairs and strings, so like let's define another function like g of a, and then we can just, well, try to change it somehow, right? But the thing is, if we do like g of word, right? And then we print word. Notice how the word didn't get changed. In fact, we can even do the same with numbers. The numbers will change. Well, it should change. Oh, I guess we're reading from A. That is why we're setting A equals. But as you can see, this A here, right? You're changing A, and A is like an arrow that points to numbers. So like when you change anything here, you're really changing numbers. Now here, the reason why it didn't work because it's kind of like declaring A as a new variable, but it's a bit more tricky than that. Because technically, you are not allowed to redefine a variable that's already like outside that exists somewhere. So if we do like numbers equals blank, well, if you do g of numbers, well, it's not allowed to change the outside one. When you do, so suppose we have like number equals 5, and we try to reassign it in a function, and then print num, right? And if we do, like, well, we don't even need a parameter, I guess, in this case. So if we just run G, well, it prints 6, and now if we print num again after, well, it's still 5 because this num here is kind of like a new variable, but only within the function. So when you make a new variable, it's important to know what you're like, what you want to use it for. So if we don't set it to 6, well, it also prints 5. It first checks if there's a local, which means like within a function, if there's a number already defined. If there is, then it will use that number instead. If there isn't, well, it's going to check outside of it, is there a number used? And then it sees there is a number and it's num, and it's 5. So it uses that instead. So even if we do this, right? If we try to increase num by 1, it says, well, it's not defined within the function, and it's not allowed to change the outside one. It can only read the outside one, but it cannot change it. Just like how we cannot just randomly change strings or whatever is inside the tuple. It's kind of, it's basically the same, and you cannot change a number if it's outside of this function. So, yeah. All right, do you guys have any questions? Anything? Do you guys have any questions? If you understood everything I talked about so far, say something in chat. Okay, then. So I guess we don't have any questions so far. All right, then. So remember when we talked about, oh, like if, so if I say like if number equals 5, then print number equals 5. And then I could say like else number is not 5, right? So if I change number, then it's not 5 anymore, right? But what if I also want to detect if number is 6? Well, I kind of have to do this, right? If it's not 5, and then inside this else, I say if, well, if number equals 6, prints like number is 6, right? And then if it's also not 6, print this. Well, this is kind of long, isn't it? So instead, in Python, it's actually just else if, and you write as elif. And what it does is that it checks everything. Like if the above if fails, if it first goes to this, it checks this instead. Now it only checks it if the top if doesn't apply and goes it goes false. So if I say number equals 5, top number equals 5, and it's going to print num is 5. No, it doesn't check the elif. It only checks the elif. So if I say like elif number is less than 6, right? So if I do num is less than 6, well, if I say number equals 5, well, number is equal to 5, so it prints num is 5. Well, num is also less than 6 because it's 5, but it doesn't run this because the top if already ran. Now say if I have 4, well, it goes to the elif and it does not go to the else. Well, with all these, we can actually make like a calculator, right? So I can say number 1 is equal to like input of, oh, and the first number, right? Like I say, operator equals input of enter operator. And then I can have a num2. Number 2 equals input of enter second number. No, the thing is, well, these are not actually numbers. What you typed in. So if I type in 1, well, this is actually like a character, and it's a character that says 1, and it's not an actual number 1. So what we want to do is we want to convert it to a number so we can convert it to integer. Then we can say if operator is equal to plus, then we can print number 1 plus number 2. And else if, right, elif operator is equal to minus, and print num1 minus num2. Then elif operator is equal to, well, multiply, print num1 times num2, etc. And then instead of typing else at the end, you could do another elif, and then you don't actually need the else. Else is not required. Just like you can just write a plain if. Not every if comes with an else. So with this now, what we can say is, well, enter first number. If I do 10, enter operator, divide, and enter second number. 5. Well, yeah, it's 2. But what if I want to do decimals? Well, it cannot convert it into an integer, right? So that's the difference. So float, basically, It means decimal. So 5.1. Now it's converted to a float, which it just means decimal. So if I do this, well, it gives me 10. Yay. So now we have a calculator. Yeah. Do we understand everything so far? You type something. You guys type something in chat if you understand, so that I know you guys are here or not. Okay, I guess. All right. Kind of. All right. So if if you have questions, like please ask. Just so I know you have questions. So well, input we take whatever you type, right? And this is just what it prints up here. And then when you type like 5.1, it converts it into a decimal, which is called float. Floating point number. If you try to, this also works if you just convert to integer, but then when you try to do decimals, it doesn't work. So yeah, this is how we can make a calculator. And so far we have talked about lists and tuples and how we can have, well, listing tuples, and you cannot change anything in tuples or strings directly, right? So now let's talk about the final data type of Python. So there's actually a data type called a dictionary. Now, what does a dictionary do? Well, a dictionary is kind of like what you would expect. It's basically a dictionary in real life. And it does basically the same thing. You can have like a word you want to look up and it's like a definition, kind of like that. So I can do like month conversion. And then how you would make a dictionary is you would do curly brackets. And I could say convert January. Well, convert Jan to January, right? And then you will type comma for a new thing. Right, I can just go on. Oops. Apparently, I just realized I can't actually spell. And if it goes on like kind of like a new line here, don't worry. And then, well, May is just May. And this actually works. Well, it just means that when you look up May, the thing that comes with it says May. If I just complete this. Almost there. Oct stands for October. stands for November, and DC stands for December. So now we have, well, like a month lookup table. So how this works is, well, similar to lists, you can actually do a month conversion, and then in the square bracket, for a list, you will type like what position the element you want, right? So here we can actually, instead of like numbering here, we just look up the thing we want to look up. So January, well, it takes Jan, and then, well, it looks like this. So basically, you're defining your own indexes in dictionaries. So for a list, right? So if I have like months, well, I'm just cut it short. But like for a normal list, you would just do something like this, right? And this will give you the first thing. But for dictionaries, you're defining your own index. And if you try to do index of 0, it's going to give you an error, say 0 is not in there. Key error. It just means that it's not in there. Well, if you wanted to like work just like a list, you can just do this. Just have the indexes be numbers. So if you change those to numbers, well, now it works exactly like a list because the indexes are numbers now. A list is basically a dictionary that has numbers as indexes, or numbers as the things you look up, right? So now this basically works like a list, except it's very long. The thing is, you can set your own like key, if you will call it, so that instead of typing this, if I change this back to JAN, then you will have to type this to see January. So it's kind of like a list, but even more useless. Yeah. Okay, do we understand about dictionary, everything I talked about dictionaries so far? Make it sound respond. Okay, so I'll take it as we have no questions about dictionaries. Yeah. Okay, so I guess we all understand dictionaries. Well, dictionaries outside of Python, it's just kind of like a Python thing. But in Python, fun fact, everything is a dictionary. Everything. That's how Python is actually coded. Now let's talk more about for loops. For is a very powerful thing. You can do for, well, like if I have months, right? I could say for a month, in months. This just takes everything inside months and goes through it one by one. Right? As expected, it does this. It goes January, February, and March. Well, what we can do is actually, this doesn't just work on lists. This works on anything you can go through. Anything you can go through one by one, it will go through it one by one. So if I have word equals hello, well, there's nothing stopping us from saying for character in word and print the character. Now what this does is, well, it just prints every single letter. Hello, hello. Right? Well, what about tuples? Well, for numbering, well, I guess T. Well, of course, this works as well. It goes 1, 2, 3, 4, 5. Now, dictionaries, however, are a bit interesting in this regard. So if you try to do for P month conversions, then print key. Well, what it does, it doesn't print the actual thing. It prints the index of each thing. So if I get rid of the other ones to make that you guys see more clarity. So it actually prints like those things in front of like the indexes, if you will call, or the keys. So what you type in here, and it prints that. Now, what if you want, say, like what is after the colon, or what is behind the key, right? So what you can actually do is just like month. Well, since you already have the index here, or what you would use to get this value, well, why not just use it to get the value, right? So we can just say an index of key, and then it will give you a chart, kind of like this. Now, yep, do we understand this part? Yeah. No, of course just we can go through a lot of things, right? We can go through range has a start and end from 0 through 5. Well, it doesn't print 5. And then we can do, well, if the index is 0, then, well, this is the first iteration. Yay. And then if it's not 0, then it's not the first iteration. So this, well,
It gives you a first iteration on the first cycle of the loop when it goes to 0, and then goes through 1, 2, 3, and 4, and then it's not 0, so it's not the first. So that's how, well, you can literally go through everything. Just to prove my point, well, remember the zip thing we used earlier? Well, we can just do for pairing zip of numbers and months. And then print the pair out. Well, it works as well. Remember when we tried to print this zip of numbers and months? When you try to print the zip of two lists, it gives you like just this thing, zip object at whatever address. Well, a for loop can actually just go through it just fine, since it's technically kind of like a list. Now, since we're already here, let's talk a little bit about lists in lists. So if we just get rid of everything else. So if I have a number grid, it goes one, well, listing lists. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is a listing list, right? Well, so how this works is that, well, if you print number grid at the 0th index, it gives you the first thing in this big list, which is the small list, right? So this will print 1, 2, 3. Now, what we can do is we can say from the smaller list, also take this first element, and this gives you 1. And this is kind of confusing, but we'll use 2D listing lists a lot. So what if we do 1 here? Well, what it does is first it still takes the first list from this big list, so it still takes 1, 2, 3, but then it takes the second element, which is 2. So the first bracket, well, the first number in the bracket here, it gives you what row it's in. And the second number here, it gives you what column it is in. So we can do, say like number grid, bracket 2, bracket 1. So what this does, well, it takes the element at index 2, which will be the third list in the big list. So it takes 7, 8, 9, and then you take index 1 from this third list, which is 8. Well, index 1 means the second element, so this gives you 8. So let's talk about commenting the code. So in Python, you could do hashtag, and this will create a comment. And then you can type whatever after it, and this will be only a comment, and it will not be run inside the code. Now, comments are actually very, very important, because what this allows is that it lets people know what your code does when they look at it. So if I print this, well, print 5. And well, imagine if you don't know what it does and just look at this. I could write a comment above, say this writes 5 on the right side, right? No, I could also say like put a comment above here and say, well, this is this is an example of lists in lists, right? Now people have a much better understanding of what your program does. So you will actually see comments a lot if you try to find other online Python codes. Yeah. And last thing for the day is this function called try. So if I type try, well, we don't really know what it does yet, right? Number equals converted to integer of your input, enter a number, then print you types, and well, plus convert to string number. What if I type? It doesn't work if you just type try. You need to accept. Accept will run when this fails above. So if I accept and print, you didn't type a number. Or you didn't enter a number. So I have to, and if I enter a number and it tries to convert it to an integer here, right? Well, it can be converted into an integer, and it says you typed 8. And if I say A, I did not enter a number and it goes to accept. Well, how did it know I didn't type in a number, right? So normally, without this try, if I type A, it gives me an error, right? What try and accept does is that it tries to run this code. And when it runs into an error, it goes to this accept part. So it will run everything in try until it runs into an error. And then it will run the accept part. But everything before it still ran. So if I print 1 here, enter a number, A, and you didn't enter a number, well, it still ran these 2 lines of code until it ran into issue with this integer conversion, right? 1, well, yeah, enter a number, 5, and type that. Well, but a blank accept is not very useful because sometimes we want to know what happened, right? Exception, or like there's a lot of things you can put in here, but you would do except and what type of error, and then you can do different excepts for like different errors. So without this except part, right? I just do enter a number at type A. It says value error, right? So if I try, and I accept, well, accept value error. And when I type A, it still says you did not enter a number, right? But if I give it like another error, say, well, a list equals just empty, and I try to print out something from it, well, it still throws an error. But now it doesn't go to this except part because it is not a value error. So if I do another except, well, I guess it's not indexed out of, it's indexed out of what range? Well, yeah, but basically you can do things like this, except I forgot this what this name is. But you can accept different errors and have them run different parts.